Here's the solution to Z6. Z6, they give you a function, but not a sort of in a straightforward way. The function that they give you has a constant in there, and they're not telling you what the constant is right now. So k is some positive constant, and they want us to find the first and the second derivative of this function. Fortunately, taking the derivative with a constant involved is easy. The derivative of a constant times a function is a constant times the derivative of the function, so for this term, that k just sticks with it. I just take k times the derivative of the square root of x. I might think of the square root of x as x to the 1/2 power. And then, of course, I need to know the derivative of ln x. Well, the derivative of that is 1 over x. So there's the first derivative. Again, it's the first derivative is going to have a constant in it. There's their solution. They did that right. They kept the square root in there. At this point, I probably would have kept everything in terms of fractional exponents, which you're allowed to do. How do you find the second derivative? Well, you take the derivative of the first derivative. So make sure that you can take derivatives like this. They typically don't give points just for being able to take derivatives. So these are a couple of pretty easy points right here. All right, now it gets a little bit twisted. For what value of k does f have a critical point at x equal 1? What does all that mean? So there's some value of k where this function right here has a critical point at x equal 1. What does it mean to be a critical point? It means I'm at a value of x where the derivative of this, the first derivative, is either 0 or undefined. So when x equals, and I want this to happen when x equals 1. This is kind of turned around a little bit. I have this derivative, and I know that x equals 1. I got to find out when this derivative is either 0 or undefined. And that now depends on k. Well, there's no k in any denominator here, so f prime won't be undefined. In other words, no matter what happens with x equal 1, no matter what happens with k, f prime won't be undefined. So somewhere, though, f prime can be 0 at some value of k. So what do? We find f prime of 1. That is, we put 1 in for x. We get f prime of 1. We set f prime equal to 0. Solve for k, and you get k equals 2. So at k equal 2, f has a critical point at x equal 1. So now that we found k, now that k equals 2, how do we know that that's a relative minimum, a relative maximum, or neither? There's two ways to justify this. We can either use the first derivative test or the second derivative test. And they really did set us up for the second derivative tests. Why? Because they made us find the second derivative as the part of the question before. So, well, how does the second derivative test go? When I am at a critical number, so when x equal 1, remember we already know that k is 2. At x equal 1, what is the second derivative? Is the second derivative positive or negative? And the answer is, well, the second derivative is greater than 0, so the second derivative is positive, which means f is concave up. So with a second derivative being positive at a critical number, there's no choice. That is a relative minimum for the function. This is a drawing of f with a tangent line at the critical number. Okay, so all of that means, and here's how we would justify it. At this critical number, x equal 1, the second derivative is positive. Therefore, by the second derivative test, f has a relative minimum at x equal 1. You guys are probably more used to justifying this by the first derivative test, which is perfectly valid to do. It's a little bit harder, but it's not terrible. When k equals 2, f prime equals this. So this is just this derivative with k equals 2. And you can say that f prime of x, this thing, changes from negative to positive across x equal 1. And when the first derivative changes from negative to positive by the first derivative test, f has a relative minimum. Notice here, the first derivative is changing from, well, f, don't mix these up, f is changing from decreasing to increasing, which means that f prime is changing from negative to positive across x equal 1, and that's just exactly what we said. If f prime changes from negative to positive across a critical number, again, it has to be a minimum. There's no way it can be a maximum. Lastly, they ask us a question about an inflection point. For a certain value of k, now k isn't 2 anymore, the graph of f has a point of inflection on the x-axis. Find this value of k. Well, all right, what does it mean to have an inflection point? It means the second derivative is changing sign. And what does it mean to have an inflection point on the x-axis? Well, that means it has to have a y-coordinate of 0. So this thing has to change sign, and this has to be 0. That's the only way I could have a point on the x-axis, is if the function value was 0. So where does the second derivative change sign and the function, the original function, is equal to 0? Well, they set them both equal to 0, and you get two equations, both with k and x. You solve them simultaneously. They just set this equal to that because they're both equal to k. And you get a k value equal to 4 over e squared. If you can see your way through this problem, it's not very difficult, but you have to put a couple of things together, and don't be afraid of having to resort to doing, let's say in this case, 2 equations and 2 unknowns. Solve them however you can solve them. Okay, that's Z6.